Okay, so in our last video, we talked about that one of the great approaches to solving a problem is to match it to things that you've seen before. But if you haven't seen a problem before, you can't really match it to anything. So let's talk about what to do when you haven't seen a problem like this before. All right, so we're in the planning phase. We have our prompt, we've analyzed our prompt, we know what we're doing, we're counting the number of prime numbers less than n, which we know to be a non-negative number. So one of the very first things that we should do is actually determine the answer by creating a few short test cases. This means picking some kind of inputs, right, that work with our prompt. And you want to pick some small inputs. Solve a very small version of this problem first. But don't pick one or two because those are usually kind of unique in how you handle them. So pick a small n like 5 or 10. That's a really good place to start. Then you want to mentally determine the answer. Now, I know that 2, 3, 5, and 7 are the only prime numbers under 10. I know that because I know a little bit of things about prime numbers. But what I need to do is actually write the data out manually and then kind of pretend that I am a robot. I'm going to walk through the steps of actually determining how I know that those numbers are prime, and then I'm going to talk out loud about the decisions that I'm making. By doing this in an interview, you demonstrate that you understand the prompt and the problem, and then this will allow you to develop a process even if you have no idea where to start. Then what we want to do is write down the steps that we took in order to find the answer. And we want to perform the same set of steps for a larger n just to make sure that the set of steps that we took is repeatable for multiple types of input. Okay, so let's do a little bit of that together. Let's just walk through the algorithm by doing it ourselves and pretending that we're a robot and writing down those steps, okay? So I'm going to write n equals 10 just to kind of cue myself in. Not because I'm really writing code, but because I just want to keep a note for myself. This is the input that I was given. Okay, so let's just write out each of those numbers. 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, great. Now, we've got all the numbers from 1 to 10, and what I'm going to do is I'm going to go through each one and determine if it's prime. Now we know that 1 doesn't count because 1 is only divisible by 1 in itself, but it is 1, and we don't really count 1 as a prime. Now, 2, what we need to do is take a look at 2 and say, okay, how do we know that 2 is a prime number? Well, 2 is only divisible by 1 in itself, and it's not 1. So 2 is prime. I'm just going to write 2 is prime because it meets our conditions. 3. Now, how do I know that 3 is prime? Well, is it divisible by only 1 in itself? Okay, yeah, that's true. It's only divisible by 1 in itself. But how do I know it's not divisible by any other number? Well, there's only one number lower than 3 that it could be divisible by, right? 3 can't be divisible by 10. That doesn't make any sense. We're looking for whole numbers here to come out, and so what we have to do is conclude that 3, since it's not divisible by 2, is a prime number. Okay, 3 is prime. Now, 4. All right, is 4 divisible by any numbers lower than itself, other than 1, of course? Well, it's divisible by 2, so not prime. All right, 5. Now, 5, is it divisible by 2? No, it's not divisible by 2. Is it divisible by 3? No, not divisible by 3. Divisible by 4? No, not divisible by 4. So this is a prime number. Okay, so let's see, 6. Is 6 divisible by 2? No, or yes, it is. So it's not prime. Okay, 7. 7 divisible by 2? No. 7 divisible by 3? No. 7 divisible by 4? No. 7 divisible by 5? No. 7 divisible by 6? No. So this is a prime number. Alright, I've got kind of a flow going. I kind of know what's going on here. You know, it looks like my steps are starting to shake out. I'm doing the same thing over and over again. With 8, I'm going to take the same approach. I'm going to try dividing it by 2, and it looks like it's divisible by 2, so it's not prime. Let's look at 9. Is 9 divisible by 2? Nope. Is 9 divisible by 3? Yep. So it is not prime. Let's look at 10. Is 10 divisible by 2? Yep. So it is not prime. So let's go through that again, and then let's just write down the steps, okay? So n is 10. 1 doesn't count. 2 is prime. And the way that we know 2 is prime is we just know, right? We didn't really make a lot of decisions other than asking, hey, does 2 meet that criteria? Now, what we did do once we got to 3, because there's numbers lower than 3 that aren't 1, is we went to the next number, go to the next number, and then is 3 divisible by 2? No. So that's the question that we asked ourselves, right? Now it can really help to just write out all these steps. So I can say 3 is prime. I made that decision after I checked to see is 3 divisible by 2. Since I found out that 3 is prime, I went on to the next number. Go to the next number. Then I took a look at 4. Is 4 divisible by 2? Yes. So then I made a decision. 4 is not prime. Let's see. 5. Go to the next number. Alright, is 5 divisible by 2? No. Is 5 divisible by 3? No. Is 5 divisible by 4? No. 5 is prime. So now I kind of have an idea of like what decisions am I making? When do I make those decisions? What questions am I asking of what parts of the data, right? We're starting to develop a structure just by going through this process. Go on to the next number. 6. Is 6 divisible by 2? Yes. 6, then I determined, is not prime. Go on to the next number. Is 7 divisible by 2? No. Is 7 divisible by 3? No. Is 7 divisible by 4? No. Is 7 divisible by 5? No. Is 7 divisible by 6? No. 7 is prime. Go on to the next number. So you can see these patterns, right? Let's say, all right, go on to the next number. Is 8 divisible by 2? No. Is 8 divisible by 2? Let's move on to 8. Is 8 divisible by 2? Yes, it is. 8 is not prime. So this is how we're determining. This is how we're making those determinations. You'll note that I'm taking note of every time I make a decision, every time I change something, every time I ask a question, right? Anytime I'm comparing some data to some other data, and then what conclusion I came to. How did that evaluate? And then I made another decision down here, right? So we can keep going here. We can keep writing out all the steps. Go on to the next number. Is 9 divisible by 2? No. Is 9 divisible by 3? Yes. 9 is not prime. Go on to the next number. Is 10 divisible by 2? Yes. 10 is not prime. So you can kind of see this pattern here, right? How did we determine whether or not something is prime? Well, you have to get all no's to all the questions about all the numbers beneath it. That's how we know that it's prime. As soon as we get a yes, we have to say that it's not prime. So anytime we see yes, it's not prime. All right, so let's move on to the next video.